Cool. I think we're recording now. All right. So triangle congruence conditions. So we did triangle similarity theorems. Remember we did like side, side, side similarity. We did side angle, side similarity. We did angle, angle similarity. We're now going to do something analogous to that, but with congruence. Congruence means not just they're the same shape, but are also the same size. And there's going to be five ways of proving that triangles are identical or congruent. So when we're looking at congruence, it's all about the triangles being identical. So we want to make sure we have just enough information to make that conclusion. So the first one you're going to see, which is already kind of all spelled out for you, is SSS, side, side, side. If you know two triangles have corresponding sides are congruent, so for example, let's say it calls like A, B, C, and say it calls D, E, F. You see how AB and DF line up, right? Notice how also BC and DE line up. And lastly, AC and EF line up. So in this case, if you have three pairs of corresponding sides of equal length, so three pairs of corresponding sides of equal length, then you can say the two triangles are identical. So we call it side, side, side. So sometimes we're going to be asked, hey, here's some information. Let's prove that these triangles are congruent. And that could be one of the ways you could prove it. So side, side, side. Hopefully that seems intuitive. If all three sides are congruent, all three pairs of sides are congruent, correct. Now, what we did with similarity, we wanted to make sure the sides were proportional, right? Like, oh, if the side's 2, 3, like if you had like say 2, 3, 4, you don't have to write this down, but like, well, tell me, so if I had 2, 3, 4, and like 4, 6, 8, obviously these are not identical, but they're similar because the sides were proportional. Now we don't care about that. We actually want them to be equal, of equal length, not proportional. So that's how it's different.
Those would not be.
Those two are not congruent, clearly, because they're different sides. So I would need, all the sides, all the corresponding sides to be the same. Okay, another one is going to be side angle side, SAS. We already saw this with similarity as well. But we need the pairs of corresponding sides not to be proportional, but to be equal. And of course, angle in between, very important, angle in between has to also be equal. So it can't be, for example, if this is ABC and that's DEF, then we can say triangle ABC. And then when you do congruence, you got to write like that. Equal sign with a little squiggly sign. So triangle ABC is going to triangle DEF. And you have to make sure you go in the right order. Very important, the angle has to be in between. Very, very important. Has to be in between. So if I have something like this here, that's not okay. Because that's no longer SAS. What would that be instead? Yeah, so don't be an ass. No, just kidding. Okay. Or SSA, it's a more appropriate way of saying it. But if you do ASS, that's fine, I don't care. But that doesn't work. Okay. It does work if there's one extra condition. We'll talk about that in a few minutes. That can work actually, but it has to be one extra condition we need, and I'll talk about that in a few minutes. But for SAS, the A has to be in between the two sides. The angle has to be in between two sides for SAS to be true. Is that your question, Vic? Or we're good, yeah. Yes, and we'll talk about it in a few minutes. That's called hypotenuse lake theorem. We'll talk about that in a few minutes. But yes, that's the only way that could work for SSA. Okay, ASA. If you have two angles that you know are the same, two pairs of angles, sorry, two pairs of angles that you know are the same, and the side in between, so the S has to be between the two angles, then that will also be congruent. So that's ABC, and that's DEF. Then again, we can conclude that ABC is congruent to DF. And that's ASA, angle side angle. But the side has to be in between the two angles. Very important. Collect good. Yes, you do. Yes. Yeah. When we did similarity 100%, we had to have that as well. Yes. Yeah, very good.
The ratios and that, like, is that not going to come back?
No, no more ratios. No.
Okay.
No, we're not. Actually, it'll come back when we do three-dimensional geometry, which won't be until sometime March or April, I think. Then we have to look at that again.
But like for now, it's always
No,
going to be like
it's all equal. No ratios, right? There's also another. Yeah, so good.
Wait,
Yeah.
okay, it's not a public question.
We'll say yeah, because we're kind of in a good rhythm right now.
It's
It's on Stranger Things.
No.
Okay. All right. We'll come back to it later. Let's hold on to that thought. Okay. Then another one is AAS, or sometimes I like to call it SAA. It's up to you whether you put the S first or S last. I don't really care. But the side is not between. So here the side was between for ASA. For AAS or SAA, it's not between. So notice that this side here is not between those two angles, right? So if I were to label like this, ABC and DEF, then again, ABC is congruent to DF. Because notice how A goes with D, B goes with E, C goes with F, right? So that's another way you could prove them. And there's ways like you could explore it, but we're not going to really care about that. I'm just telling you what to look for. And lastly, hypotenuse Lake theorem, HL. And what this states, I'm just going to draw it. Actually, can I move the screen? Yeah, I can move it. Here we go. Yeah, for hypotenuse Lake theorem, it is SSA. Or actually, let me rephrase that. Only time SSA works. So what Faith said about a couple minutes ago, it's the only time it works. So yes, you have, if I call this A, B, C, so I make the right angle A, then B and C. So I do the same thing here, D, E, F. So why is it called hypotenuse Lake theorem? Are the hypotenuses the same? Yes. Is there a pair of legs the same? Yes. And lastly, do you have two right angles here? Yes. So you have two right triangles, and it so happens that the hypotenuse and the legs are the same. Then we can deduce that everything else will be the same. That the other leg's the same, the other angles are the same, everything's the same. So those are the 5 ways. That's it. Hypotenuse leg, AS, SAS, ASA, and of course SSS. So we're going to talk about we're talking a lot about this this week and next week. If you want more reference, this is all kind of like all explained again and shows you the diagrams. So it's all there. And this is just so if you want to kind of quiz yourself on it, you could use this to draw it out. You could do that later. So anyhow, so that's just a reference. Now let's actually do some problems. And by the way, on the notes, this is the last page of the notes. I think some guys were asking, like, is there a reference sheet for proofs? Like, what can I do? Yes, this is it right here. So remember we talked about reflexive property, we talked about all these other properties. You have a whole bunch of them right there. Vertical angles, we talked about linear pairs, we talked about alternate interior angles. So this is why this is probably the most complex unit we have, because there's so many different things you have to piece together. It's a puzzle, essentially. That's what you're doing. You're putting the pieces together for a puzzle, but there's not one set way. So you have to kind of use a lot of logic when it comes to this. So we'll kind of ease you guys into this a little bit. So we'll do the first couple pages here. Not until the 19th, 2 weeks.
And that's a break.
Well, 3-day weekend, which is nice. So yeah, it's good to have 3-day weekends. So we're gonna do the first couple pages, and then I'll have you guys work on homework after that. That's when we start break, ski week. That starts after the 13th. So anyhow, let's get to the notes now. All right, so let's look at 6-1. All right, so taking a look at this, what do you notice about these two triangles? Well, they're congruent, right? For what reason? SSS, right? But here's the thing. There's a formality, Kira. Thanks. There's a formality, right? the formality is that we have to actually write all the steps. We can't just say, well, they're the same. Yeah, well, duh. Of course they're the same. Look at it. I mean, I know they're the same, but you have to respect the formality that goes into it. Mainly because as you guys take more advanced classes like Algebra 2, Pre-Calculus, Calculus, when you go about those kind of problems, even though you're not doing written proofs, there's just this formality of showing your work and explaining yourself. This is really what we're trying to build here. So you can see on the wall there, and by the way, all your posters from the quilt project, we're going to start putting them up um, later this week so you guys can see all your beautiful artwork. But we're also going to do a project on proofs, like you see right there, and like trying to, and I don't know how the project's going to work exactly, but we'll get to that sometime this semester. So let's talk about how to prove this. So first, I have to give you some given information. So what are we given here? And I have to tell it to you. I mean, it's pretty obvious just by looks of the diagram. But what are we given here? We're given that AB is congruent to what?
DF.
Yeah, AB is definitely the same as DF. That's true. And they both equal what? Okay. Also, that AC equals what?
Uh, 7.5. EF, which is 7.5.
Correct?
Does it matter if it's like EF?
No, it doesn't matter. No, no. And then CB,
Is equal to ED, which is equal to 4.5.
correct. So actually, that had been provided. And we're being asked to prove that triangle ABC is congruent to FDE. Today's January 6th, yeah. It's actually the 5th anniversary of the riot on the Capitol. You guys remember that? Yeah, I was actually home. I was like, whoa, what is going on here? That was nuts. You guys were doing Zoom school at the time.
I was in person.
Oh, you were in person back? Okay. Yeah, some people were back in person. We were still closed
How do you know that there's gonna be 3 steps?
because I haven't looked at the answer key.
Mhm.
So,
Like,
yeah, so this is why this is tricky, right? Because I mean, if I do give you like some of the prior, or if I kind of like, give you a partially filled out proof, then you know how many steps there are. If I don't, that's where we have a little leeway. As long as it makes sense, like that's why there's not one just set way. That's why these are a little tricky. Sometimes you're not really sure. So you have to kind of like understand the logic that's going on here. So the first thing I'm going to do, always your first step is you're given. This is always the first step. So I'm simply just going to copy everything I just wrote. So I'm going to say AB equals DF, which of course equals 6. AC, which equals FE, of course equals 7.5. And CB, which equals ED, which equals 4.5. And it's a pain. I really don't like this, but we have to do it. You got to write this out. So no shortcuts. Okay, so that's given. This is always the last step. Always the last step we want to prove. Triangle ABC. And that's your statement, right? You're making that statement. Now, the reason, I mean, we know what to say because we've just talked about it, but sometimes it may not be obvious until you're fully done with the proof. So we'll wait to put the reason at the end. But I think it's pretty obvious we're going to say side, 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 right? But before that, how can I deduce that this is true? Is that fine? I know AB equals DF equals 6. Um, it's kind of oh, wait one sec. Okay, I'm getting a little ahead of myself here, but it's fine. We're asked to prove that these are similar, not congruent. My apologies. So slight correction here. We're asked to prove that these are similar, not congruent. We're going to do that eventually. So my apologies. I got a little ahead of myself there. Okay, because obviously, if I'm trying to prove they're congruent, yeah, and actually Zoe asked a great question. How do I know those 3 steps? Actually, if it's congruent, there's only 2 steps. Because once you know AB equals DF, and this equals this, and this equals this, of course you're going to say this, that they're congruent. Of course you are. but I didn't read the instructions carefully. That's my fault. We're trying to prove these are similar. So we're trying to prove they're similar, then we do need to prove that the ratios are the same. So how would I prove the ratios are the same? What would I write as my second step? Like, what's the ratio between AB and DF?
Oh,
DF. What was that ratio equal? Okay. Is that true for the other two ratios? Yeah, what's AC to FE? Also one. What's CB over E over DE? Also one. And what did I do to make that happen? I divided, right? So there's a property called this.
Property.
Correct.
Fall.
Yeah. Wow. How do you know that? That's actually impressive.
I knew. I just wasn't gonna say it.
Well, this reference sheet at the end tells
My
me.
math teacher taught me it last.
Okay. Okay.
Actually.
The reference sheet.
Well, but.
It's all right. But the reference sheet at the end kind of lists all those different. So whatever you're doing to make things happen, like, okay, I'm from the first step to the second step. What did I do to go from the first step to the second step? I divided, right? And why did I divide? Well, how did I know to do that in the first place? Because if I'm asked to prove things are similar, then I need the ratios to be the same, right? Um, so yeah, that's why I divided. And of course, this is side angle side. Sorry, side similarity. So again, my apology. I thought we were proving congruence, but right now we're proving similarity. Click, go ahead. Yeah, it would. Yeah, because you have to prove the ratios. It would. But if it was congruence, I only need two steps: the given and side congruence. I didn't need that. I didn't need step two if it was congruence. If I was just because it's pretty obvious from the given that side is the most logical step.
For similarity, you have to show that there's.
The ratio, you do. Yep. Because that's the definition of similarity. That's why. Congruence, you just need to be equal. It's already given to you, so you just make the statement afterwards. Yeah.
Oh, the similar.
Yeah, so that's part A. Now for part B, are these triangles also congruent? Well, yes. And that's because the ratio equals 1. It's 1 to 1. So of course they're congruent.
Could you just say like S because SSS with like the congruent symbol?
For part B,
Yeah, or do you have to explain what the ratio is?
just the ratios are 1 to 1. I mean, yeah, I mean all the sides are equal. You could say that too.
What if
Yeah,
you
you could say that. That's fine.
said this instead of the ratio?
Sure. Yeah, that's fine. Yeah, I mean, yeah. So then for part C, we talked about the symbols, right? So we know that just a squiggly line is similar, but an equal sign at the squiggly line up top is going to be congruent. So how's the congruent symbol related to the similarity symbol? Well, similarity which is a squiggly sign, means same shape. And then equal, of course, is an equal sign, right? Is the same size. So combined, we get this, which we call congruent. I mean, it's kind of I shouldn't say this, but it's kind of dumb because I mean, obviously they're equal. They're going to be the same shape. It's a formality, really more than anything else. So yeah. So that's why it's combined. The equal sign with the tilt with the little squiggly sign. To yeah, that's what's happened there. So write the congruent statement. Well, now I know triangle ABC is congruent to triangle FDE. So if you actually were to measure the sides, like got a ruler and measured it, or got a protractor measured the angles, But great, those are equal. So we know that we're congruent. Now in this case, so that one's kind of interesting. What do you guys think about party? Looks kind of funky. Yeah. Here's what it's so here's the thing. Looks are deceiving
They share like.
because they don't look the same. Well, not necessarily. No, that's not really what's
Geometric.
correct. Right. Mhm. So it's not to scale. Because clearly if I got like a ruler and measured this side and that side, they're gonna be different. But you can't go based off looks. So what I do is this. I like to actually redraw the triangles. So best to redraw and reorient each triangle. So BDC, which looks like this, right? And by the way, BC is shared between both triangles, right? And then this is gonna be a little tricky. I'll do my best job to draw it. So even though AC looks bigger than, or sorry, AB looks smaller than BC, you can't go based off looks. Um, so in this case, yeah, side congruence. Clearly, we're given a bunch of things here. And you have to use the reflexive property as well. I'm not going to write out a proof for this because we're going to do another proof. Actually, we're not quite doing a proof yet, but we're going to talk about how to identify these in just a moment. But the key idea, looks are deceiving, not to scale. So best to redraw and reorient. And you can see for yourself, oh yeah, okay, I see how the triangle sides. And BC equals BC, that's reflexive. So you have to make that statement. So click it.
They like the same size, but aren't they only like similar on the size?
Well, no, they're congruent. What do you mean?
Like
Well, you told AC and BD are the same, right? Yeah. Oh yeah, maybe that's your confusion. The markings mean they're identical. That's what the markings mean. Yeah, not we probably did do that, I think. Actually, no, we did the similarity. You're right. We did probably use the same kind of symbol, but in this case, it means they're the same. They're congruent, yeah. Yeah, actually, that might be I can see your confusion. Because I think we did use that same that kind of methodology of marking for similarity. Yeah, no, it's now at this point when we see that, we would assume, but I would tell you that anyway in the given information. Like I'd say, given this is congruent, not proportional. I would tell you that. Okay, we'll do one more page of notes, and I'll have you guys get head start on homework so you can get it done. Say in class, we get out what time? At 1:55 p.m. We're doing great. All right, so here, what information do I need? So there's actually a Desmos activity. Actually, let me pull up that Desmos activity right now. Give me a sec here. I think it's I'm kind of doing this on the fly because I haven't actually looking at it for the first time right now. So um shoot, really?
Got it.
Log in. Hold on. Just give me a school email.
I'm so tired, this means I'm. Oh, I know.
Yeah, I don't know if we'll do this today because I haven't really gone through this. Let me try one more time here. Yeah, maybe on Thursday.
Do you get the owl for Thursday?
Oh my,
Nice.
Ella's set right now.
Wait, are there Sunday hours?
Yeah, we'll do that later. It's fine. Okay, anyway, let's get back to the SIC 2 here. Okay, so I'll tell you right now, of these 8 examples here, 5 of them are congruent, and 3 is not enough information. So I'm going to have you and your table groups determine. So 5 of these pairs
Is B congruent?
work out. I'll tell you in a moment. 5 pairs are congruent and 3 pairs not enough info.
But, like, with the lines, you said whenever it has the same amount of lines, it's similar. But then why is C the same amount?
No. Well, whenever you see the same amount of lines, it just means they're going to be identical, congruent.
So the angle on C is identical.
There's 1, 2, it's 2
Correct. Right. Right.
This is also equal.
Yeah, so it's
So it's SSS.
Let's look at part A. Let's mark it up. That's the same as that, right? 11 same as that. 70 is the same as this. Okay. So you guys have 2 pairs of sides that are the same? You do.
Yeah.
You have an angle, a pair of angles the same? You do. Is the angle between the 2 sides?
Yeah.
So what do you call that?
Yeah.
SAS.
No, but I'm confused about C.
So that's yes.
For C, how is the angle the same?
They're the same, but you can't. But see, here's the thing. This right here is SAS. But what's this one right here? So do we have enough information here? Yeah, you need to know what's going on with some of the other angles before you can deduce if these are the can be congruent. We don't have enough information. So go and try the other 6, and then I'll go with you guys in a moment.
Is there one where it's 1 angle, 2 sides, and it's not SAS?
One angle and 2 sides.
SAS.
Yeah, it could be no, that could be SAS or SSA, but SSA is not okay unless you have right angles.
We do have right angles.
No. It's an angle, but it's not a right angle.
Wait, you can't do right.
Like, not prove.
Which one? For what choice? D. D. Oh, wait 1 sec. No, that will work. The D will work. Okay, these are the same, right? That's because of alternate angles. Those are the same vertical angles.
Divide by 6.
ASA, but it's a different line.
Oh, so here's the thing. You could use a few options. So like what I just did right now is I did AS for both of these, right? Because if you think about it, this lines up with this, and that lines up with that, and these sides line up. And the side's not between the 2 angles.
Okay.
But I think what you were doing was you're probably doing this.
What now? 6 doesn't, like, it's not in the middle, like, the same.
Well, but you have a few options. What if you decide to do this? You could have done this also, and that's totally valid. That's totally valid there because because in this case, you're saying this angle is the same as this angle because of alternate angles, and that's same because of vertical angles, and that's same in between. So now you're using ASA.
Okay, got it.
So
Wait, is AA one? For the
no, because that would just be similar, not congruent. You don't know for sure. So that's part G, I think, right? Yeah. So Faith, to answer your question, that's why these are tricky because there's not one set way. There's multiple ways you could prove this. So those are both valid. But B, there's only one way to say it. That's a yes, and for what reason? Side, side, side. Yep. Side, side, side. Okay, then for E, F, G, H. G, do you have any sides?
No.
No, if you don't have any sides, forget about it.
But what about if it's like AA?
Doesn't matter.
It's a non.
It's only sufficient for somebody. Yes, thank you, Connor. That's correct. Bless you. Now we know this side's shared, but notice what's happening at SSA. SSA, you don't see any right angles here. So that's a no as well. That's also not okay.
Wait,
What about E?
yeah.
What about E? What do you guys think?
me too.
No, it's enough.
Side,
Yeah, parallel.
side angle stop.
Yeah, parallel, right?
The SAA.
So and they share that side is reflexive. So these are the kind of proofs we're talking about. Like here's what would happen. I'd have to let me label it actually. If I were to label the sides, let's say I call this A, B, C, and D, right? So I'd have to tell you B equals D. I have to tell you that. I also would tell you that AB is parallel to CD, right? I'll tell you that. And that's it. That's all I'll tell you. I'll only tell you two things. But looking at the diagram, you recognize, well, of course, angle BAC equals DCA. For what reason? Alternate angles. Of course, AC equals AC. For what reason? Reflexive. Okay, now do I have enough to put it congruent? 100% you do. Because now I have side angle, or angle side. So I'd have to kind of I'll give you some information. Oh, these lines are parallel, these angles are the same. But then you have to give me the other reasons. Oh, there's a reflexive. Oh, there's alternate angles. Oh, okay, now I have angle side, right? So that's yes. So basically the way a proof works, it's like a logical flow. Like logic had to go from one step to the next to be able to get to the end goal, right? Yeah, give me the stuff in between. And like you guys say reflexive or alternate triangles, all the things you've learned, everything's building upon itself now, right? That's what you're doing here. So BE is an excellent example of a proof I could give you guys, where I'll give you a couple pieces of information, tell you what to prove. And you got to fill up, give me the, so like I'll give you like the bun, like the top bun. You got to give me the meat and the cheese and the vegetables, right? You got to give me the rest of the sandwich. I'll give you the bread. I'll give you the bread, but I won't give you everything else. So, good. For H, which ones? These here?
Or it's connected.
This right here? How do we know that? No. For H? No, we don't know anything's parallel right now. For H. Right? No, we don't know that. So we can't say that. Well, for F. Yeah, because they share that middle side, right? Yep. Side, right. So if I were to give that to you, I'd say, well, I mean, that's a pretty easy proof, but you
Say.
SSA? No, that's not a thing though. That's only if you have a right angle. It's not a thing. Yeah, it's not a thing. Yeah. Good. You good? Okay, cool. All right. So that's as far as I want to get today, because that's where Mr. Davis got this class. And I still don't really understand the assessment activity, so that's okay. But we're gonna do the rest of these notes tomorrow, not tomorrow, sorry, Thursday. But you guys have the homework packet in front of you. Let me show you the homework packet. So you guys can get a head start. And I'll publish the answer. I'll put it in Schoology later today, and I'll give you guys hard copies of it later in the week.
How long were your kids out for?
2 weeks. Yeah.
Wait, doing hot chocolate?
Oh, I thought for break. Sorry. Oh, no, couple hours. 2 hours.
Like 3 hours.
No, about 2 hours. Yeah. Okay, so homework is I haven't put in Schoology yet. By the way, everyone has been added to the new Schoology page. So we have a new Schoology page for the semester. I haven't posted the Schoology yet, but the homework, the packet's right here. I do suggest you guys do your homework on a separate piece of paper, so it's easy for me to read what you're trying to do. But 614, it's kind of old stuff. 615, solving for sides. You might need a calculator for some of these problems. 616, it's should be a separate packet. It should be this yeah. A ball charger. I do. Sure, actually, I do have a ball charger.
You just do homework 1.
Yeah, so homework 1, guys. Yeah, I'll give you a calculator right now. And we could charge that. Yeah, then there's some multiple choice question, some explanations. Yeah, so just go through all those problems there. Yeah.
From like
Great question. Someone asked that in Mr. Davis' class last period. I think hold on to your tests. That might be good. But any of like the homeworks or classwork, you could toss it. But the yeah, I mean the tests are just good just to kind of reference like just to make sure you understand like all the previous, because I mean we still use that stuff in the second semester. So I'd say hold on to your tests, but the notes and homeworks you could toss. So or any other stuff. Yeah.
It could be from last semester too, like our full final.
No, no, it's gonna be nothing that's unique. Like geometric mean, for example, was very unique to the first semester. We won't do that. But I mean, yes, do you need to know Pythagorean theorem? Do you need to know like, what's a Q? Yeah, trig, like, yeah, sure, like previous knowledge you should know, but anything that's like very, very specific to the first semester, no, we don't do that. I don't think any class can do that. Unless you're in an AP class, that's a different story. Because AP exams are, the whole course. So yeah, just working homework, guys. We got about 20. You can hold on to it or just actually, yes, actually, if you want to write your name and I'll see if comes closest.
One about those.
Here.
Oh, yeah.
That's good because she wants to read books, so it's location. But it's just so annoying. She's just grabs them all, puts them on the ground.
Answer.
I'll wait till everyone turns it in.
He was like, I prefer it.
We have you recycle times.
Because he said it's easier for him to do it.
Yeah, I mean, you can see the building.
Oh,
Oh, God. Sure, yeah, actually.
I'm on 619. But now I'm on 623.
okay, I'm on 614.
Yeah. Somehow.
What's angle?
Yes, give me a sec.
680.
What's your eight?
Let's see.
I'm doing the Did you just like,
Oh, Jake.
how did you like name which school you did, right?
I know. You can say it in it just says. Oh, I did trade and I did high five.
Oh, okay.
So Sunday was fun, never really like.
No, I was wondering, like, you did have.
I won an iPad.
I do. I just like to record on Zoom, so I hope we're not having that.
And I have an Apple pen too, but then
Yeah, I know. I just like.
bought the.
I know. I just have to download it.
It shows on when you're like.
What was that?
What do you like? See it?
Like I did split, so I did Stranger
My
Things
phone, I showed
on
on my phone and I was
Christmas
just like.
Day. Meeting.
But you always use your phone.
Yeah. It's not big of a show.
Then you're like,
It's just like my camera.
Wait, do you guys watch that? How do you guys watch Chamberlain?
I fell asleep.
I haven't watched any of the things.
Yeah, those are classics. Yeah. Yeah, but like, yeah, well, Stranger Things I couldn't watch the kids around, so it's a little hard. So, yeah. I don't watch my laptop or what. Really at night.
You're But I missed it.
Oh, no, I watched the other one.
I love
Yeah.
that. I think it's kids.
It is, but it's not. It's like we're time.
Yeah.
Yeah, we can stick further X, so you would first solve that, which is. and then you
Which
divide
is
it.
yours, Maggie? So,
Heroes.
that's curious.
Oh, wait, I knew that. Let's not answer.
Not a bad guess.
Okay, that makes me questionable.
Okay. And, oh, yeah, you're right. Okay, hold on. Let's see your.
So scared. What if we get extra?
Mystery, can I take it back? I said 6 hours. I said 63. I got 64.
At first I got 64, but then I counted again and I got like 50.
I don't even know.
What did you guys do some money? I did 20.
Wait, I need to do the money mystery. I first write it down. I did 48. May I write it? You would need.
Yeah. That's
Wait, 40. I'm putting my.
I just feel
Like my.
how many people came,
asking for.
how many people came for 30 minutes?
Alright,
I need it all.
thoughts on my second guess, or for the, no, for the. Okay, that's not promising.
Okay. I don't care.
Those really, I'm a little.
How was your guys'
First trial.
Wait, there's so many pages.
You're like absolutely that.
Wait, so.
Wait,
I don't know, there's so much.
Oh, wait, this is 7.
All right, so the closest one for the books.
What
Or the closest.
was it? What was it?
What do you say, Connor?
It
It was 78. It's 78.
You know what?
Yeah.
Is it both books? Yeah.
Yeah, because they're very thin. And then for a profit, William, you're the closest for the profit. Yeah, what do you say? What do you say? Well, no, you said that's the number of books you said. The
Oh,
profit. Yeah, it was $14.50.
Oh,
what?
that's a lot of profit.
$14.50, yeah.
Wait. Oh, I had high hopes for it.
They sold about 15 or so cups of hot chocolate and like including the fuse meat, so
I thought they sold.
like 30 or 40. No. We made enough to sell about 24, 25 cups. And the weather was crappy too.
$200.
On one day?
We were out there for like
Wow.
11.
That's really good. How much you sell each one for?